So, today's fun and games. Let's start with the basics. 15th of April 2020. One ruler. Underline the date. Today's topic is Pythagoras. Says Theorem. And we're underlining our title as well. There we go. So, stuff you'll need for today's lesson. You're going to need a ruler, going to need a pencil, going to need a calculator to work stuff out, and a pen. So, first of all, what is Pythagoras' theorem? Pretty sure you've seen this in year 8, so we'll just do a brief recap. We're going to draw ourselves a right angle triangle. And this side this is the longest side, this is the hypotenuse, it's opposite the right angle. These are the shorter sides. Doesn't really matter which way around they are for now. We'll call this one A and we'll call this one B, and I'm going to call the hypotenuse H. And Pythagoras' theorem states that a squared plus b squared equals h squared. Now, other variations of this formula are available. I like writing it like this because it makes the distinction that the hypotenuse h is the one that's on its own being squared, and a and b are the two shorter sides. So this is the way I'm going to write the formula when I'm doing my calculations. We'll look at a proof of this a little bit later on. There's an extension opportunity here. First example. And we always draw a diagram for these questions. All right. 8, 15, H. So, I've got a right angled triangle. Two shorter sides are 8 and 15. Let's have some units. Let's call these centimetres. But we don't know what the hypotenuse is. First thing is quote the formula. A squared plus b squared equals h squared. Now we do the substitution. So the two shorter sides, 8 and 15, doesn't matter which way around they go. 8 squared plus 15 squared will equal h squared. Work these out. 8 squared is 64. 15 squared is 225. Equals h squared. Add those two together. 289 equals h squared. Notice that when I do my formula and substitutions, things are staying relatively lined up. So I can see the movement as I'm solving the question working down the page. Finally, we're going to take the square root. And the square root of 289, if you use your calculator, will come out as 17 centimetres. And let's underline the answer. So that's the kind of working you should be doing. And that's the kind of diagram we should be doing as well. I didn't draw this to scale, but it is a right angled triangle, and I did use a pencil and ruler. I have labelled my sides, and I have solved the problem. Now in this particular example, I deliberately chose numbers where I knew I would have a whole number answer. And so this particular set of 3 lengths for this triangle in Pythagoras' theorem, 8, 15, 17, this is what's known as a Pythagorean triple. All right, and there's another extension opportunity here if you want to research Pythagorean triples. There's lots of them, and there's rules about the ways you can generate them. So let's look at another example. That was example 1. Okay. Example 2. This time we're going to start by knowing what the hypotenuse is, but we're going to have to work backwards and work out one of the shorter sides. So we'll say that the hypotenuse has a length of 23 centimeters, and this side has a length of 16 centimeters, but we don't know what this side is here. But the way you start the question is still the same. Quote the formula. A squared plus b squared equals h squared. And if it helps you, on the diagram you can label that this side is b and this side is h. Let's substitute our numbers in. A squared, we don't know that one. B squared is 16 to be squared, and h squared is 23 squared. And note this time the information that we don't know is in this bit of the formula. Let's now square these numbers. A squared plus 16 squared is 256. Can't remember 23 squared off the top of my head. 529. And then from this stage onwards it's just algebra. We're just trying to find a. And I need to get a squared on its own before I can get a on its own. So I'm going to take away 256 from both sides. Let's make a note. In fact, let's just do a... There we go. A little separation down the middle of the page there. And we're going to take away 256 from both sides. And when I take away 256 from the left-hand side, I've just got a squared. And when I take away 256 from the right-hand side, I've got 273. Again, try and keep things lined up so we can see the movement in the equation. Finally, we need to take the square root of both sides to get a. So we want the square root of 273. There we go. Let's type that in properly. Square root 273. Hope you can see that. And then if I press this S-D button here, that's going to give me a decimal readout. We'll go for one decimal place. So 16.52271164 to one decimal place will just be 16.5. 16.5 centimeters, one decimal place accuracy. And again, I'm underlining my answer. Keeping things looking nice and neat. That's very important. So this should give you an example, an idea of what the typical layout should look like when you're doing these calculations. It's tempting to write less and try and go straight to some little quick calculation that gives you the answer, but knowing the structure of how these work will allow more advanced problems to be considered. Let's have a look at an example of a more advanced problem. Alright, let's call this example number 3 because it's example number 3. So let's consider a square. Draw ourselves a quick square here. The side length of the square is the length of the shorter sides of the triangle, and not only that, they're both the same. So I'm going to focus on this triangle here. I don't know what this side length here is. I'm going to call it x, and I'm going to call this one x as well. As usual, quote the formula. A squared plus b squared equals h squared. And my two shorter sides are my a and b, so I've basically got x squared plus another x squared equals whatever 70 squared is. Now we'll process the algebra. x squared plus another x squared. They're like terms. Let's collect our like terms, and we get 2x squared. And 70 squared, did I really just reach for the calculator then? 70 squared is 4,900. Now we're trying to get x on its own, and I can't take a square root yet because of this multiplier 2. So I need to divide both sides by 2. X squared is half of that, which is 2,450. And then finally, by taking the square root of both sides, x will equal 50 equals, push that button, 49.497, so 49.5 centimetres. Underline my answer. Now it's at this stage I might decide to apply a little bit of common sense. I'm working with a square that has a diagonal of 70 centimetres. So if I do my calculation here, and for some reason I get the answer of 146 centimetres for x, I would be a bit suspicious of that as an answer, because x is going to be less than 70 because it's a shorter side. So try and keep an eye on your calculations for any numbers that are popping up that look a little bit ridiculous and not quite what they should be. Okay, hopefully that should give you an overview of the type of calculations you're going to encounter when you are working on Pythagoras' theorem. Thank you very much.